In this video, we are going to talk about the midpoint sum method. So previously, we talked about the right sum, the left sum, and then based on this problem, the right sum is overestimation, the left sum is underestimation. I want to take a look at what happens if I take a point in the middle of a rectangle. So let's find out. So we use the same function, y equals to x squared, and then the domain x goes from 0 to 1. I want to approximate the area under the curve using midpoint sum. Okay, so since I would like to use 4 subintervals again, so I have a line from 0 to 1. I want to cut this into 4 pieces. So the first cut, I cut that right in the middle at 0.5, and then one more cut at 0.25, and then one more cut at 0.75. So this is a 1/4, this is a 2/4, this is a 3/4, right? So since you are using midpoint, what is midpoint? Midpoint is the middle. So midpoint is the middle of an interval. So let's use a different color for that. So midpoint is the middle of an interval. That means between 0 and 0.25, where is the midpoint? So we use 0 plus 0.25 divided by 2, that is 0.125. So which is right here, 0.125. And then we take 0.25 plus 0.5, and then divided by 2, we have 0.375. So this is 0.375. And then the next one, the middle, is 0.625. And then this one, the middle, is 0.875. And then if you take a look at the distance between 1.125 and 375, the width is 0.25, right? Okay, so let's put that on the pictures. So first we cut that into 4 subinterval. So this is a 1 cut, another cut, and then another cut, right? So let's make it more even. So 1, 2, and 3. And then this is a 1/4. This is a 2/4. This is a 3/4. Okay, so the first interval is from 0 to 1/4, but I am not taking the 0. I am not taking the 1/4. What should I take? Let me go back to yellow. So between 0 and 1/4, the midpoint is right here, right? So when x is equals to 0.125, do we agree that there is a point on the curve? Let me repeat this again. When x equals to 0.125, there is a point on the curve. When x is equals to 0.375, there is a point on the curve. When x is equals to 0.625, there is a point on the curve. When x is equals to 0.875, there is a point on the curve. And they are the midpoint of each subinterval. Okay, so I have 4 yellow dots. So here is the next step. So you extend one line to the left and one line to the right, and then you draw your rectangle. Look at the next point, one line to the left, one line to the right, you draw your rectangle. It takes you a little practice, just a little practice. 1 point to the left, 1 point to the right, and then you draw a rectangle. 1 point to the left, 1 point to the right, and then you draw a rectangle. And then what about the area? So here is the area. So that's the first one, that's the second one, that's the third one, that's the fourth one. And then your next step is you will have to estimate the area under the curve for me, which means I want you to tell me the area of these 4 rectangles. So since we are using midpoint, we are going to use M4. So what is the width? The width of each base, the base of each rectangle is 1/4, right, or 0.25. So the first rectangle, let's go from left to right. We have the base. I am looking at this rectangle right here. The first one on the left. The base is 1/4. How tall is that? So to find the height, you have to plug in 0.125 to the function, which is f of 0.125. So this is base times height. You get the area of the first rectangle. The next rectangle, the base is always 1/4, and then the height is you plug in 0.375. And then, or if you can do this, f of x instead of y, and then 1 over 4 times f of 0.625, and then the last rectangle 1 over 4 times f of 0.875. Okay, so you can factor out the 1 over 4, and then you have this 125 plus f of 0.375 plus f of 0.625, and then plus f of 0.875. Okay, and then can you tell me what that equals to? So since f of x, is equals to x squared, I can do an example for you. 125, all you have to do is you square the 125, right? So this is 1 over 4, 0.125 square plus 0.375 square plus 0.625 square plus 0.875 square, and then you use your calculator to approximate that for me. So this one is approximately equal to 0.328 125. So if you take a look closely, use your eyes to look at the corner of the strip. So this one, so it looks like we overestimate this, right? So it looks like we overestimate this. So for every rectangle, we have a little bit of overestimation for every rectangle. So that means this is still an overestimate. So let's do a comparison. Since we did a midpoint, left sum, and right sum, so this is M4. And then what about the left sum, the L4? The L4 is equals to 0.21875. The right sum for subinterval is 0.46785. Again, the underestimation and overestimation, you have to look at the picture and then make a decision. You cannot just look at the number and make a decision. You have to use your eyes to look at the picture. So the left, we have 0.2. The right, we have 0.4, and then the midpoint, we have 0.3, right? It looks like the midpoint is the average of the left sum and the right sum. Now, the next question is, which one is the best? I have left, I have right, I have middle. Which one is the best? The answer is, you cannot just decide which one is the best right here. So to find the best estimate, you have to use, the answer is, you have to use as many subinterval as possible. So let's put the conclusion right here. To find the best estimate, use as many subinterval as possible. And for this, I will prove this in the next video. Okay, so that is the end of the midpoint sum method. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel for me. Appreciate your help and support as always. I see you all in the next one. Signing off for now.